Hi everyone. Today discussion is a circular queue. First of all, we need to understand the concept. Why we are learning circular queue? Why we are learning circular queue? Simply, in a normal queue, whenever you are deleting the information, when you are deleting the information, suppose this is the queue, with some values, we are taking. Okay. So what we have discussed in the last session, suppose here some values are there, like a 53794, some values are there. If you delete, always deletion from the front, then all the remaining elements will shift, move forward. Reason is what? Here, that front location is a fixed location. Front is fixed in a queue, right? So shifting of elements in case of deletion, shifting of elements take much time. That's why they introduced the concept of circular queue. In a circular queue, just like a queue only, but there is no shifting of elements. I'm explaining like this. I'm taking one queue with the size is some size we are taking. Suppose size 8 size we are taking. Size 8 we are taking. That is only just representation in the form of circular queue. Only the representation in the form of circular queue. The 0, 1, 2, 3, 4, 5, 6, 7. Sir, how can we create? See there, here front value is not fixed value. So that's why initially front and rear starts with a -1 and -1. Is not pointing to anything. Sir, how can we create? I'm using the previous things only. Same insert, delete, display. I'm just writing it's a CQ. There we have taken size is 8 na. So same 8 only I'm taking the size. 8. Initially front and rear values taking -1, -1. -1 and -1. Remaining logics, I'll change it. If it is 3, remaining is almost the same. 4. The codes also, we will write it again. The peak not required is display, is full and is empty. The same skeleton we are using to represent. The first thing is, see here, now it is empty na? Now it is empty. Initially, as soon as you have created the queue is empty. Either front equals to -1 or rear equals to -1. You can say that it is empty. Any condition you can use. Any condition. Empty means what? Either front equals to -1 or rear. So here I am taking that rear. Remember that. It is empty condition. No, sir. I'm inserting the first element. the first element of that queue. First element means what? See here, into the zeroth location, we have to insert zeroth location. So here it is, front and rear values both become 0, 0. Initially -1, Now front and rear both are pointing to same location only. Then only you can insert into this one. So front is pointing, rear is pointing. For that we are writing, whenever you are inserting, full case later, if is full. For that we are writing the code later. Directly Q is or CQ is full. Circular Q is a full. If not, we are inserting. How we insert, sir? This is for first insertion. If rear equal to -1 means what? If rear equal to -1 means what? No elements in the circular queue. You are going to insert the first element. So by that time, make front value and rear value equals to 0. Make front value and rear value equal to 0. But we need to insert using rear, na? Insertions from rear, deletions from front. The concept you must use. So CQ of rear is equal to element, that what you have sent, that you are passing here, and simply the message is element added to queue. Element added to queue. Few more is there. If else concept is there, but that is later. We have inserted the first element. Sir, this is the only element, na? Sir, suppose if I call DQ, I mean deletion, I have called deletion. Remember the point. Deletion means whenever you are deleting this element, when Q contains only one element, last element, only one element is the last element. By that time, front and rear pointing to same locations only. Same locations. Nothing but here, if is empty, directly we can say that you cannot delete. Printf CQ is empty, else first we are going to delete %d. Deletion means what? Front variable you have to use. Front. See, suppose from front is pointing to 10, na? Deleted consider. Deleted means empty, na? Empty means it should come back to the same position only. Front equals to -1, rear equal to -1. Front equal to -1, rear equal to -1. When front and rear both are pointing to same one, front and rear equal to -1. Back to empty case. Here also two more are there. I'll explain. This is first insertion. In comments I am writing, it is first insertion case. So first time just make it 0, both. This is last deletion, last element deletion. By that time again it will go back to that empty case. No, sir. After first insertion, again remaining, I keep on inserting. So increase the rear value. Rear will come to here. Only rear will move 20. Again, sir, 30. rare increase, again 40, again 50, only rare plus plus. Front we should not move. 60, so rare will increase. 70, again 80, 80. We keep on inserting, we keep on inserting. Now rare reached size minus 1. So then we keep on inserting means what? Simply rare plus plus. This last else block execute. This is first case. This is first case. This is all the remaining cases. Remaining all. 1, 1, 1, 1, 1, 1 increases rare plus plus. And element will be added. Element will be added. Is keep on increasing, increasing, increasing. That is. Okay. Finally, after element added to the queue, whenever it reaches this 7th position, look at this, queue is full now. Front equal to 0, rare equal to size minus 1. When full condition, when front equal to 0 and rare equal to size minus 1, then we can say that queue is full. Sir, okay, queue is full. Now I want to delete some elements, sir. Deletion means what? Delete. After delete, change the front value, front plus plus. After delete, change the front value. After delete, change the front value. After delete, we keep on deleting and changing. Change the front value. After delete, up to here, 5 elements we deleted. Front is pointing to 5th location. Nothing but we keep on deleting. First, last element deletion is okay. Remaining, simply we are writing front plus plus. Delete front plus plus, delete front plus plus, delete front plus plus. Now, sir, now insertion chance is there. Now look at this, queue is not full. So many locations are there to insert. Now by this time, look at this, both are failed. If rare equal to minus 1 failed, rare plus plus also will fail. Sir, why? Rare value 7, na? Rare plus plus means what? 8 will come, 8. Is it there 8th location? No. So whenever it reaches size minus 1, nothing but 7th location, again it should starts with 0. It should starts with 0. Whenever it reaches, whenever that whenever that rare value reaches size minus 1, rare value reaches size minus 1, simply again rare value starts with 0. Then element will be stored into CQ of rare and element added to the queue. Here, now that rare value will come to this position, and here it is 90. Next again, rare plus plus. Look at this, rare plus plus 100. Rare will increase 110. Rare will increase 120. Rare will increase 130. So here it is that rare is coming to this place. Now observe. Rare is behind the front. Front is a 5, rare is a 4. Now is also queue is full. Na? This is another situation to become queue is full. So two situations are there. Two situations. Here, for full, one is this situation. Not only this, or whenever rare plus 1 equal to front or front equal to rare minus 1, anything you can write. Okay, so front is equal to rare plus 1, we are writing this one. So two conditions represents, either this condition represents q is full or this condition represents q is full, represents q is full. Okay, sir, then we keep on deleting. Suppose 60 deleted, sir, 60 deleted, front plus plus, 70 deleted, front plus plus. Now sir, front is pointing to 7th location. Sir, now if I delete 80, now front plus plus will not work, sir. Front should come to here. So same story, even like rare, front also whenever reaches size minus 1, 7th location, again front also starts with the 0th location again, 0th location again. That is, this is the way. Now here observe this, sir. Here it is insertions and deletions. Okay, what about the display? Display is the same story. If it is empty, then simply we are giving that CQ is empty. CQ is empty. If not, else. See, look at this. First case I am representing. First case I am representing. I am inserting only these. Front, rare is what? Rare is a 3 na? In this situation, 50. Suppose this is the case. When rare behind the front means what? If front is less than or equal to rare, then we need to repeat only one loop like this. Front is 0, rare is a something 7. Okay, for I is equal to front starting I less than or equal to rare I plus plus, printf all elements CQ of I. This is okay. But sir, suppose this is the situation. Sorry. This is the situation. Front is moving. Front is staying there. Now rare. Sir, now look at this. Two situations required. First, these things you need to display up from here to here. Next one, these things we need to display. So one for loop is not sufficient. So we have to take the first for loop is repeating from front to size minus 1. And the second for loop you need to repeat from 0 to rare. Two for loops required. So else one for loop is for repeating front to size minus 1, again second loop is repeating from 0 to rare. This is the case. This is the way we are executing that code. When you are executing, let me check any errors. No errors are there. No errors. Then you can keep on performing that insertions and deletions. So the only thing you need to understand, if they ask, what is the difference between Q and circular Q? Q is taking so much of time while shifting the elements in case of deletion, but in circular Q, not like that. We keep on moving that front location. That's it. Okay. I'll share this code in the WhatsApp group. Next one, please everyone execute this code and I'll upload the video. Please watch the video.